Here we are going to solve for the correct images and pre-images of specific vectors here, but we are going to decide first which of the two vectors v and w here will have an image and a pre-image. Okay, this is under linear transformation defined by a matrix. To identify properly which vector is to be used to solve for an image or pre-image, we need to understand that our matrix A here is a 3 by 2 matrix. So following m by n, our n is 2 and m is a 3. Why is it very important for us to have this? Because the linear transformation that are given by or defined by a matrix is in this form: r to the n to r to the m. And since our n here is 2, our linear transformation for this given specific matrix is r2 to r3. In short, what vector you can see that is an element of R2, in this case vector V, we are going to show its image, meaning a certain R3 using this vector. And our vector W here is now an element of our codomain, R3. We're going to solve its pre-image, an R2 pre-image. Okay? And we can do that using this process. We have here the linear transformation of the vector V. We use here vector V because it's V that is clear to be part of the domain because it's on R2, is equal to the product of your matrix A and the same vector V. So with that, we are going to substitute here our matrix A, 1, 0, 0, negative 1, 1, and then 2. To be multiplied with our vector V, we have 1 and 2. Another way for us to determine whether this is correct or not is by looking at the product here. The product here is defined as we have here 3 by 2 matrix times 2 by 1. So this is defined. Because if you're going to push using W here, that would mean 3 by 2 by, to be multiplied by, in matrix form, that's 3 by 1. This is not defined. In short, again, this is really correct here. So, simply multiply, and you will have here the image of your vector V. 1 times 1 is 1. 0 times 2 is 0. So you have here 1. 0 times 1 is 0. Negative 1 times 2, negative 2. 1 times 1 is 1. 2 times 2 is 4. 1 plus 4, we have here 5. In vector form, we have 1, negative 2, and 5. And this is the image of your given vector V. Okay? Now for the pre-image of our vector W, we still need to use the same. So we have the linear transformation of vector V is equal to A times the product of our A times our vector V. This is actually equal to your W because vector W is the image of this. And then we are going to solve for vector V. And since our vector V is in our domain R2, okay, this would mean that our vector V has components V sub 1 and V sub 2. And we're going to use this here. As we substitute our matrix 1, 0, 0, negative 1, and 1 and 2, multiply it with your vector V, V sub 1, V sub 2, and this is equal to your vector W, 2, negative 5, and 12. Hence, we are expecting here to have equations such as this. 1 times V sub 1 is V sub 1, 0 times V sub 2 is 0, V sub 1 is automatically 2. Let's just simply continue even if we know that it's already 2. 0 times V sub 1 is 0, negative 1 times V sub 2 is negative V sub 2 is equal to negative 5. In the third equation, 1 times V sub 1 plus 2 times V sub 2 to V sub 2 is equal to 12. Again, we already have this value. And with this, you can divide both sides by a negative sign of negative 1. V sub 2 is positive 5. These are now the components of the pre-image of your vector W. But of course, if you're not yet convinced, you could always try using this. V sub 2 is 2 plus twice 5, that's actually 12. That's 2 plus 10, that's 12. So this is really final. And now, vector v, okay, we'll have the components of v sub 1, which is 2, and our v sub 2, which is 5. And this is not just any vector, but this is more specifically the pre-image of vector w. So this is how we identify the image and pre-image of certain vectors. But of course, we need to really come up with this so that we would know which vector to be used. And then this is how we do it using the linear transformation defined by a certain matrix. Thank you very much for watching.